Thomas's 1.6. This is chapter 1 stuff, so it's more basic than a lot of the stuff we've done. And you'll see that of these four these four kinds of equations that we'll look at, one on each side of his sheets. Some are old, some are new, some are combinations. Let's look at number 1, A. Got 4x to the 4th equals 12x squared. You can see that we've got an exponent that's higher than a 2. We're still going to do it the same way. Zero factor property. Send this over. We get 4x to the 4th minus 12x squared equals 0. There we've got a 0. Now let's factor. They both have a 4 in common, and they both have an x squared we can pull out. If we pull out the 4 and 2 of those, we've got x squared here, minus sign. 12 divided by 4 is a 3. X squared's all sitting at the door, so we're good here. Now we've gotten the 0, we did the factoring. Now let's use the property that allows you to say each one can be set equal to 0. We want to get to x, so let's divide by 4. Oh, now we got something new. I'm not sure if we've done that. I think we've done this a little bitty teeny weeny bit. We need to get to x. It's being squared. You want to unsquare it. Those are opposites. Ta-da, that's now an x. If you take the square root of one side, you need to take the square root of both sides. Square root of 0 is 0. This is an even radical or even index. We're taking the square root, and so we need to consider both the positive and negative versions of that, and they don't have 0 does not have positive or negative versions, so it just has 0. Moving on, let's send this 3 over. We get x squared equals 3. We're now in this position. We've got x squared. We want x. So take the square root. Squaring and unsquaring cancel each other out. Whatever you do to one side, you want to do to both sides. Since this is an even root, 2, 4, 6, or 8, we have to consider both the positive and negative versions. So there's our answer. We kind of have 4 answers. We need to have 4. We have 1, 2 there. 3 and 4 if we had a plus or minus here. So we do have 4 answers. That's what the exponent tells you. Let's look at B, the other problem of this. This has got 4 terms, so this is going to be a factor by grouping problem. Zero factor property. Send these guys over to the other side. There's our 0. Now let's do our factoring. We have 4 terms, so we're going to factor by grouping. This is sort of a little weirdo. What do these two have in common? We're only going to factor these two. They both have an x squared in common. Pull that out. You get 2x plus 3 when you factor out an x squared out of both of those. Bring down the minus sign. These both have a 4 in common. We know that these two sets of parentheses have to match, so just go ahead and put it in there. But make sure it works. Negative 4 times 2x, cool. Negative 4 times 3, wonderful. And now you can see that these two, again, have something in common. Let's pull that out. And what's left over is x squared minus 4. That equals 0. So we got the 0, we did the factoring. Now let's set each piece equal to 0 and solve. Move the 3 over. Divide by 2. There's one answer. Move the 4 over. Take the square root of both sides for the same reasons I went over in 1a. X equals, you put the radical on, and that's an even index. Positive, negative 2. 2 answers there, 1 answer there. 3 was the exponent. That's what we were expecting. Okay, so those are both just factoring problems. Let's look at number 2, which is going to have radical equations. So each one of these will have a radical in it. You can see that A, B, and C all have radicals. Start with this one. This is kind of the opposite of what we were doing here. Here we had x squared, we put the radical on. These have a radical, and you have to do the opposite of that, which is squaring. So squaring and unsquaring cancel each other out, and we get x, and that's exactly what we wanted. We want to know what x equals. If you've done it to one side, you have to do it to both sides. So we get an 81. Now you'll notice that at the top of the page it says always check your answer. Not all of them will work, so we have to check them on these radical equations. plug in the answer you got in place of x. Square root of 81 is a 9. 9 equals 9. This one checks. So x equals 81 is a good answer. Let's look at 2b. We've got a square root of x plus 3 equals x. Isolate this guy. So let's move the 3 over. And now we're in the same position. We've got this guy isolated. Let's square to get rid of the radical. Whatever you do to one side, you have to do to both sides. On the left, squaring and unsquaring cancel each other out, so we get x plus 3. On the right, x minus 3 squared. That means write x minus 3 twice and FOIL it out. So first, outside, inside, last, and combine those two. So we get equals x squared minus 6x plus 9. We've got an x squared, so we're going to have to factor. Let's do 0. Factor. Property. Minus 6 equals 0. So x equals 6 and x equals 1. We've got to check both of those. So checking the 1, put a 1 in up here. The square root of 1 plus 3 equals 1 again. Square root of 4 plus 3 equals 1. That's a 2. 2 plus 3 does not equal 1. So x equals 1 just isn't an answer for us. Let's see if 6 will work. Plug it in up here. The square root of 6 plus 3 equals 6. The square root of 9 plus 3 equals 6. Square root of 9 is 3. 3 plus 3 equals 6. So 6 is a good answer. Our last one is very much like B, very much like B. Let's look at this. We've got the square root of 2x plus 19 minus 8 equals x. First, get this guy isolated. So let's move that 8 over. So we get equals x plus 8. You've got to get rid of that radical. To do that, square it. If you've squared one side, you've got to square both sides. Let me scoot us down while I'm thinking about it. Squaring and unsquaring cancel each other out. This is a FOIL problem. X plus 8 times x plus 8. So it's a FOIL problem. First is x squared. Outside is 8x. Inside's another 8x. And last is a 64. Combine those two. So you get x squared plus 16x plus 64. Zero factor property. So minus 2x and minus 19. So I got x squared plus 14x plus 45. Yeah, 45 equals 0. So we're looking for, let's see, let's get this set up. We've got the 0. Now let's factor. The signs need to be the same and they need to be positive. What two numbers multiply to give you 45 that add together to give you 14? It's 9 and 5. We got the 0. We did the factoring. Now use the property. So x equals negative 5 and x equals negative 9. We have to check them, put them back in. So 2 times negative 9 plus 19 minus 8 equals negative 9. That's for this guy. 2 times negative 9 is a negative 18. Let's see, that'll give us the square root of 1. Square root of 1 is 1. 1 minus 8 gives us a negative 7. That's not equal to negative 9, so that one's just not going to work. Let's check this other guy. The check for x equals negative 5. Here we go. We got 2 times negative 5 plus 19 minus 8 equals negative 5. 2 times negative 5 is a negative 10. It gives us 9. 3 minus 8 equals negative 5. That's negative 5 equals negative 5. That works. So -5 is a good answer on C. So we had one answer there also. One worked, one didn't work. Let's look at number 3. Number 3 says equations with rational exponents. Each one of those exponents, 3/2, 3/2, and 5/4, is an exponent. This is going to be a fairly simple thing. Let's look at how we're going to do it. X to the 3/2, is that too high? No, it's not. Equals 8. Okay, we have got to make that x be x to the first power. So what we're going to have to do is we're going to have to multiply this side times a fraction that will make 3/2 turn into 1. If we multiply 3/2 times his reciprocal is 2/3, then we're going to get a 1. Let me show you how that goes. 3/2 is the original fraction. We're multiplying him times his reciprocal. You can either multiply straight through and you get a 1. There's the 1 we're looking for. Or you can cancel the 3's, cancel the 2's, and you get 1. Either way, we can change that exponent into a 1 by multiplying times his reciprocal, which is the whole thing you got to do in these 3 problems. All right, so if we have raised this piece, the left-hand side to the 2/3, we have to do it there also. So let's see what we get. Anytime you've got a number raised to an exponent, stick him under there. The denominator is the index. And then we can either put the 2 in there or we can put it outside. Doesn't matter. I prefer to put it outside so that we're not saying, what's the cube root of 64? We've got a smaller number. What's the cube root of 8? That's a 2, and then we have to raise that to the second power. So x equals 4 here. 4x is 4. 4 raised to the 3/2 power will give us an 8. And you can check that. You don't have to. These are not ones that you have to check. But that means 4 goes under there. The denominator is the index, and then we'll raise it up to the 3rd power. Square root of 4 is 2. 2 to the 3rd power is the 8 that we had in the original. You don't have to check them, though. They'll work. Let's look at B. 5x to the 3/2 power minus 25 equals 0. We first need to isolate that little guy, so let's send 25 over to the other side. 5x to the 3/2 equals 25. Still, we're trying to isolate this isolate this variable with a rational exponent. Divide by 5. X to the 3/2 equals 5. Now we're at the same place we were in our other problem. So let's raise this to the 2/3 power, because 3/2, the original exponent, times his reciprocal will always give us a 1, and that's what we want. We want x to the 1st power equals. Whatever we do to one side, we have to raise to the other side also. So put the 5 underneath there. The 3 is the index. It goes right there. And then you can either put the 2 on there, which would give you the cube root of 25, or you could have this and raise it all to the 2nd power. It's just totally your choice. Doesn't matter. Either one is acceptable. Let's look at C, see if I can cram it in here. X to the 5/4 minus 8 equals 24. Again, let's get this guy isolated. Move the 8 over, so it's a plus 8. So we get 32. We need to get this to be a 1, so we're going to use, instead of 5/4, we'll multiply the expression times his reciprocal. That'll get us to x to the 1st, because the 5's will cancel and the 4's will cancel. Whatever we do to one side, we have to do to both sides. There's 32 under the radical. The denominator goes there, and then in the end, I'll raise it to the 4th power. So the 5th root of 32, it is 2, but you can use your calculator if you're not sure. 5th root of 32 equals 2, and then we're going to raise what we got there to the 4th power, and that gives us a 16. Okay, let's look at the last kind of problems we're doing here. There are only 2 in this section of Thomas's, but mine has 4, I think. Mine has a load of them, because I'm really a fan of them, and apparently my math lab is too. They've got a load of them. So you're expected to know how to do the problems, all of these problems, but definitely you will get more practice in quadratic and form. This next kind, number 4, you will get more practice on those in my section and in my math lab. So let's see what we've got here. X to the 4th minus 5x squared plus 6 equals 0. You can see that this sort of looks like, I mean, you cross your eyes a little bit, and this looks like a regular old quadratic, x squared minus 5x plus 6. That's what we're going to turn it into. The way we're going to turn it into is by substitution. And then you're going to use this funny letter mu, just a funny letter so that you don't ever end up with an answer mu equals. You've got to turn it back into x's. So we're going to take our x's, convert them to mu's, and at the end we'll convert them back to x's. What you want to substitute for mu is that piece. What sits behind the b, the x squared there. So that's what this is going to look like. When we find an x squared, we're going to substitute a funky little letter. Start back here, it makes more sense. 0, no problem. Equals, no problem. Positive 6, no problem. Oh, there's an x squared. Instead of an x squared, let's put a mu. Then a 5, then a negative. Oh, this is x squared squared, so that'll be this guy squared. This will always be mu squared. This will always be mu in these problems. Now we've got a 0. We can factor this. Signs need to be the same, and they need to be negative. What two numbers multiply to give you 6 that add together to give you 5? That's 3 and 2. Set each piece equal to 0. Okay, this is where I don't want you to stop. The answers are not 3 and 2, because this answer is not about, this question is not about mu's, it's about x's. So we're going to have to go back in and resubstitute. In place of mu, put what we substituted there, x squared. In place of mu, resubstitute. Now we're back where we were on 1 and 2 up there. Sorry, probably number 1 more. You have to take the square root of both sides. All over the place, take the square root in order to get x equals. You put the radical on, so you're going to have to consider both a positive and a negative square root of 3. X equals, you put the radical on, so you're going to have to consider both a positive and a negative square root of 2. Those are the 4 answers. We needed 4 answers. This doesn't give us 4 answers, plus it's about mu. We need it to be about x's. So these are the answers. Let's go look at B. Same kind of problem, but using rational exponents instead. X to the 1/3 minus 4 equals 0. Again, we're going to convert this into a mu problem with mu squared and mu. So we need to let mu equal that piece right there, x to the 1/3. So we've got a 0 at the back end. That's good. Equal sign, -4. Oh, there's an x to the 1/3. Substitute in mu. Then a -11. Then an x to the 2/3. That's the square of x to the 1/3. So we want the square of mu, and then you've got a 3 in front. So there, we've converted into a normal little problem. 3 mu and mu, signs need to be different. I need to find 2 numbers that multiply to give me 4, and when I put them in here and, do the outside inside, I can get an 11. 4 times 1, and if I put the 4 there and the 1 there, I'll get an outside -12 mu and an inside +1 mu, giving me exactly what I'm looking for. So this is the correct factoring. We got it into normal quadratic form. We factored it. Now let's use the property that allows you to set each piece equal to 0. 3 mu equals -1. Divide by 3. We get a -1/3. Mu equals 4. Okay, now's the place where you're not done. You're going to have to go substitute. Bring this guy down, and in place of the mu's, let's go back to our original x to the 1/3. So x to the 1/3 equals 4, and x to the 1/3 equals -1/3. We just finished doing some of these problems. If you want to get 1/3 out of there, multiply times is reciprocal. 3, or 3 over 1, which is the same thing. So 1/3 of 3 will give us x to the 1st power, which is what we're going for. But if you do that to one side, you have to do it to both sides. So a negative, you can put this in your calculator, but a negative raised to the third power is a negative. 1 times 1 times 1 is 1. 3 times 3 times 3 is 27. Over here, do the same thing. Cube that, cube that. So 1/3 times 3 gives you x to the first. 4 to the third power, 4 times 4 times 4 is 64. And those are your two answers there.
See ya.